Have you ever been deeply engrossed in a task on your computer, when suddenly an application unexpectedly halts, perhaps displaying a mysterious error message before closing entirely? That moment of abrupt interruption, where your program simply cannot proceed as intended, is often the result of something fundamental in computing. At its core, a runtime program exception is an unexpected event that disrupts the normal flow of a program's execution. Think of it as a signal, generated by the program or the operating system, indicating that a critical issue has occurred that prevents the program from continuing its intended operation in a stable or correct manner. It is not necessarily a fatal error, but it does signify a deviation from the expected behavior. The why behind these exceptions is rooted in the program's inability to handle certain conditions or operations. This could be due to invalid input data, attempting to access memory that does not belong to it, dividing by zero, or even trying to open a file that does not exist. When such an anomalous situation arises, the program encounters a state it was not designed to gracefully manage, leading to the generation of an exception object, which contains information about the error that occurred. Understanding exceptions means recognizing that they are often a structured way for a program to report problems. Instead of crashing silently, exceptions provide a mechanism to signal that something went wrong and offer an opportunity for the program to react. Programming languages implement specific mechanisms, known as exception handling, where you can write code to catch these signals and attempt to recover, log the issue, or shut down gracefully, rather than just terminating abruptly. A key insight here is the concept of a stack trace, or call stack. When an exception occurs, the program typically records the sequence of function calls that led to the error. This stack trace is an invaluable diagnostic tool, pointing directly to the exact line of code where the problem originated, and showing the path the program took to get there. It is like a breadcrumb trail that helps developers pinpoint the root cause, distinguishing between an error in the current function and an error propagated from an earlier faulty operation. Ultimately, a runtime program exception represents a crucial point in software execution, where a deviation from normal operations occurs, offering both a challenge and an opportunity. By understanding that these are not just random crashes but structured problem reports, and by learning how to interpret the information they provide, you gain powerful insight into the stability and robustness of software. This knowledge empowers you to build more resilient applications and to diagnose issues more effectively, transforming a frustrating stop into a valuable diagnostic signal.
If this helps you fix faster, like, subscribe, and keep debugging with us.